Hello everyone. This is live session 8. So today we will talk about the numerical differentiation and numerical integration. So so far we have solved few questions about the linear inter about the interpolation technique. Now we'll move forward to solving the differentiation and the integration. So in the first class, I have introduced some of those aspects. So today we will deal with it in great detail. So let's start. Okay. So so first we will solve some theory problem. Then I will share some code where we will do, where we will solve some complicated problem. Those problem we cannot solve by hand. So first let's start with this problem. So it says that here you have a here we have a table of time versus distance, and I need to calculate the velocity using three different techniques. One is the forward difference, another is the backward, and another is the centered difference scheme. So for forward difference, so then f prime of x is f of x plus delta x minus f of x by delta x. Now now for forward difference, here uh, right. So what is the best estimate? Okay. So here I have velocity at, so here, so and for the backward, so it is forward divided difference, and for the backward divided difference it is f prime of x, f of x minus f x minus delta x by delta x. Both of them will possess an error of order of delta x, and the central divided difference here, it is f of x plus delta x minus f x minus delta x by 2 delta x. Here the order error is of order delta x square. Now the question says that difference approximate what is the best estimate you can find velocity of car at t equal to 10 seconds. Now I need to find v at 10. What will be the velocity in this case? So what I can do? Hmm, and do what I can do, I can use the I can so first I will use the forward difference technique. Just a moment. I can assume here that my delta x equal to 5. Okay. So f prime of x, here x equal to 10, equal to v of 10 is equal to x of 15 minus x of 10 by 5. Here 5 is equal to delta x. So what will be the value? The value is 700 minus 300 by 5 is equal to 80, right? And this is for forward divided difference. Now from the backward divided difference, it will be V10 is equal to X10 minus X5 divided by 5. And this value will be 300 minus 100 by 5. So this is equal to 40. Now for the central divided difference scheme, the value of V10, this will be equal to X15 minus X5 divided by 10. So it will be 700 minus 100 by 10. This result will be 60. So obviously your CDT will give much better approximation compared to FDT and VDT. So the correct answer will be 60 meter per second. Right. Now here it is a mistake that here it should be e square equal to 7.39. I have written it later. So now here I have to, here this is an example problem from the numerical integration, that is the Simpson one-third rule. Now for a bit background, what is the Simpson one-third? I will write the formula over here, that is a to b fx dx is equal to b minus a by 6 fa plus 4 of f a plus b divided by 2 plus f of b. Here I can assume h is the step size is b minus a by 2. So in general the formula is h by 3 fa plus 4 f a plus b by 2 plus f of b. Now here fa is the starting point, b is the ending point, and a plus b by 2 is an intermediate point, right? So this is the formula for a two step this is for two segment Simpson one third rule. Now here you have provided these values e to the power 0, e to the power 1, e cube, e square, and e to the power 4. Now I need to find the value of 0 to 4 e to the power x dx. Right. Now so 0 to 4 e to the power x dx. I need to calculate the value. Now see that if I just use a two segment Simpson's rule, that means the I just need 0 plus 4 by 2, that is equal to 2 and 4, right? But here e to the power 1 and e to the power 3, these data are also provided. So what to do here? Here I can break this into break the integration in this following: 0 to 2 e to the power x dx plus 2 to 4 e to the power x dx. Now I can apply Simpson's rule individually for this. Suppose this is I1, this is equal to I2. Now here I1 is equal to 0 to 2 e to the power x dx is equal to b minus a by 6. That means 2 minus 0 by 6. Here 2 is the b and a is 0 times f of a, that means e to the power 0, plus 4 into f of a plus b by 2, that means 4 of f of 2 plus 0 by 2, which is equal to 1, plus f of 4 f of 2, that is e to the power e square. Okay, and these values are already provided, so it is 1 over third e to the power 0 plus 4 e to the power 1 plus e to the power 2. Okay, right. Now the second integration I2, and the total final result will be I1 plus I2. This will be 0, this will be 2 to 4 e to the power x dx. Again, the b minus a is 4 minus 2 by 6, that is 1 by 3, times e squared, that is f of a. Okay. Can you see now? Is it better? Hello? Uh,
Sir,
Now,
excuse
is
me,
it
sir.
fine?
Sir, only small size of the screen only visible, sir.
It is small.
Yes, sir.
Okay, just a second, huh? Just a second. Let me just check. Okay, so this is the problem. One second. Mm, Now, is it fine?
I think now also same, sir. But okay, sir.
Yeah,
Can
so,
it not show the full screen, sir.
huh?
It will visible only part of the slide. This one, sir.
No, I don't.
Letters are clear, sir. But it shows
Let
in
us.
small size.
Okay, so I will share the whole PDF document. Then I think it will not be a problem. I think, huh?
Okay, sir. Okay, sir.
So here it will be it e square plus 4 times e cube plus e to the power 4. Then it will be 1 over third e square plus 4 e cube plus e to the power 4. So the final result I will be equal to I1 plus I2 is equal to 1 over 3 E0 plus 4 e to the power 1 plus e to the power 3 plus 2 e square plus e to the power 4. So this will be your final answer. Now, what will be the, if I write down the expression, e to the power 0 is 1 plus 4 times e to the power 1 is given as 2.72 and e to the power 3 is 20.09. So 2.72 plus 20.09 plus 2 times e square is 7.39. 7.39 plus e to the power 4, that is 54.6. Now if you do the calculation, you will find that finally this result will give you, just a second, you will find that finally this will give you that 53.873, this answer. Hence this option A, this is the correct option. Okay, just remember, just to see the question, that what values of fa, what values of the functions are given. Okay, if in the question it is on, if it is only provided a e to the power 0, e square, and e to the power 4, then you can just, you can simply use this formula. Okay, but here e to the power 1, the here the values at the intermediate points at x equal to 1 and x equal to 3, they are also that is also provided. So this formula gets modified. Okay, now here the, now the now if I have multiple segments, okay, remember that in case of Simpson's rule, the number of segments has to be an even number, unlike the trapezoidal rule case. Okay, now for the multiple segment case, this is the correct expression for that. Later we will solve some questions. I will show some code using how to use the Simpsons formula. But let me write down the formula for the multiple segments. A to b fx dx is equal to h over 3.
Sir, excuse me, sir.
Yes.
Sir, it is not possible to adjust the screen, sir.
Huh?
It is not possible to adjust the screen, sir, because I couldn't see the slide, sir.
What do you want to say? Tell me.
Sir, I couldn't see the screen, sir, because it is it shows in small size, sir.
You are seeing it in mobile.
No, sir, I see in laptop, sir. I use laptop because if I record this the PPT means it is also couldn't see, sir, because it is too in small.
So just a second. Just a second. Is it better now? Hello?
Now it is okay, sir.
Now it is okay?
Oh, okay, sir.
Okay. Now it is fine now? Okay.
Yes, sir. Yes,
So,
yes, sir.
so here what is the formula? The formula will be f of x naught plus 4. Here it will jump from 1 to 3 to 5 like this way. I odd. Okay. Plus I equal to 2 to n minus 2. Again, it only count the even number f of xi plus f of xn. Okay, here your x not equal to a, xn equal to b and h equal to b minus a over n. Here n is the number of segments. That means if you have some curve like this, you can you can do the integration from a to b directly, or you can break into some smaller parts, like just like this problem 0 to 4. I have it is broken into 0 to 2 and 2 to 4. Okay, this indicates the number of segments. All right, so we have to use this formula when we do the code in Matlab. Okay, so keep this handy. Now, the again question 3, again a small easy problem from the basic forward difference formula. Here you just need to calculate the value of f prime of sine prime of 1, f prime of 1. Yeah, so the calculation is pretty straightforward. Here f prime of 1 will be equal to sine 1.3 1.003906, because it is provided here that h is this number minus sine of 1 divided by 0.003906. Yeah, if you calculate, you will find this value comes like around 0.5386. Okay, just straightforward question. So option B is the correct answer. Okay, right. So now question number 4. So here I have to use the trapezoidal rule to find the approximate distance traveled by the object between t equal to 2 to t equal to 12. Okay. Now we know the formula for the trapezoidal rule for the multiple segment. So the formula is, just a moment. Ha. The formula is a to b fx dx is equal to h over 2 fa plus fb. Unlike the Simpson's rule, this formula is pretty straightforward. Equal to 1 to n minus 1 f of a plus I h. Oh, I forgot to mention that here xi equal to x naught plus I of h. Okay, and here it's same. This is the same xi. This is a plus I of h. Okay, so this is the formula. Now here h is equal to b minus a over n. N is the number of segments, like the Simpson's rule. Now here the problem is, here h for this formula, this h should be equal. Okay, h should be constant. But here you see that initially the step difference is 3, then for 5 to 7 step difference is 2, 7 to 9 step difference is 2, again from 9 to 12 the step difference is 3. So I cannot directly use this formula over here. So I have to modify the calculation. How can I do that? So this is, just a second. Now the modification process is pretty straightforward. Okay, this is so what can I do? So first I will consider these 2 points. This is my first step. Then I will consider these 3 points, because here h is constant for these 3 points. Again at the end I will consider these 2 points. So this operation will finally give me my desired result. Okay, so let's do that. Now for this first 2 point, your a is 2, b and okay. Here your a is 2 and b is 5. Okay, then I1 for this first 2 point, it is 5 minus 2 divided by minus a over n, 5 minus 2 divided by 2, that is my h over 2, times f of a, that is 12 plus f of b 16. Now here I don't have any other intermediate points, right? A is the first point, B is the last point. So only these two terms will come. This term will not appear. Okay. So what will be the result? This value is equal to 42. Now I2 for these 3 points, 5, 7, and 9. So what will be the formula for these 3 points? That is, if B is 9 and A is 5. So that is 9 minus 5 divided by 2 times 2. Why? Because it has two segments. Here I can modify this formula as b minus a over 2n. In the prefactor it will be b minus a over 2n, and here n equal to 2. That means two segments. Okay, so that's why we get 2 into 2 multiplied by fa plus fb. That means 16 plus 15 plus 2 into the intermediate points, that is 24. If I do the calculation, it is 4 over 4, 31 plus 48. So the answer is equal to 79. Okay. Now the I3 is for this 2.9 and 12. Again it will be 12 minus 9 divided by 2 times f9 plus f12, that is 15 plus 33. So it will be uh, 3 by 2 into 48 is equal to 72. Now total distance covered. Now the total distance covered between t equal to 2 and t equal to 12. Okay, so what will be the answer? Answer will be I1 plus I2 plus I3, because I1 is the distance covered between 2 and 5. I2 is the distance covered between 5 and 9, and I3 is the distance covered between 9 and 12. So if I draw the graph over here, so the first segment is 2 to 5. Okay, then then 5 to 9, and again 9 to 12. So this plot is just arbitrary plot. So here I have solved it piecewise. First I have solved for this, then I have solved for this. Okay, 5, this is 5 to 9, this is 2 to 5, and 9 to 12. Okay, so total distance covered I is equal to I1 plus I2 plus I3. So that means it will be 42 plus 72 plus 79, and the answer is equal to 193, the summation. So option A is the correct answer.
Sir, don't
Okay.
we sir, excuse me, sir. Don't we consider about 5 to 7, sir? Only we consider 2 to 5, 5 to 9, 7 to 12.
No, 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 no. High 7 is there. 7 is there. See, here's this point 7 is also included. See,
Oh,
just see the formula. Okay. So suppose you have suppose you have 3 points. Here you have a plus b by 2, and b. Now if you want to calculate, okay, suppose you are first doing the calculation, trying to find the integration from a to b using the trapezoidal rule. So what will be the formula? B minus a over 2
will be
f of a plus f of b.
okay.
Yeah.
Okay,
Now
sir.
suppose there is another point c. Huh?
Okay, sir.
Then you need to do the same calculation from B to C. Suppose your B minus A by 2 B minus A is equal to same as C minus B, H by 2. So it is H by 2 FA plus FB.
Okay.
Similarly, from B to C, it will be H by 2 F of B plus
If
F
of
of
C.
C. So finally we'll have h by 2 fa plus fc plus 2 of
C of B.
fd.
Okay, okay. Okay, sir.
So, so your A is the starting point, C is the last point. You can see it from here in this expression. 2 into 24. Here,
Okay.
here 7 is here the term 7 is already included over here.
Okay, okay,
Okay.
sir. Okay, okay, sir.
Huh. Just B is the intermediate point. So there this is as this is a common point. So the trapezoidal rule work twice here. So that's why 2 into 2, this two multi that this two prefactor comes.
Okay, sir. Okay, sir.
Okay. Okay. So now this is a logic. So this is a logical this is a logical question that Simpson's rule. So you need to find that. Okay. So now suppose so to solve this question. So now to solve this question. So let me draw some graph. The first one is suppose if you have a curve like this and you want to find the integration using the trapezoidal rule. What we generally have to do here, we just draw a straight line. Now if your graph is already a straight line, okay, if your graph is already a straight line, then trapezoidal rule will give you exactly the correct answer. Huh? So here the trapezoidal rule is exact for linear function gx equal to x plus b because this is the assumption. I have a curve, I assume it like a straight line, and then I can apply the trapezoidal rule. But if the curve is already a straight line, then my trapezoidal rule is sufficient to give the exact answer. So this option is the correct. Now, if it is a constant term, then obviously trapezoidal rule will work. This is a straight line where x is varying and also the y is also varying. A constant term, fx equal to c, this is also kind of straight line where the value of y is not changing. So trapezoidal rule will give correct answer here as well. So this is also correct. Now for the Simpson's rule, in the Simpson's rule we connect it. In the Simpson's rule we connect this with a quadratic polynomial. Okay. Now if the curve is already a quadratic polynomial, then my Simpson's rule will give the correct answer. But here the question says the Simpson's rule is exact for linear function. Obviously, this is also a kind of this is also a kind of a quadratic polynomial like this. Gx equal to 0 into x square plus ax plus b. I can write it in this manner. Okay, so linear solution is an order down from the quadratic polynomial. So this will give you the exact correct answer. Okay, if I apply Simpson's rule over here, so Simpson's rule will show the exact for the linear function gx equal to x plus b. So this option is also correct. This option is incorrect because trapezoidal rule will give you exact answer for the straight line because if for this curve, suppose this is the curve ax square plus bx plus c. I have to fit a straight line over here. I cannot directly integrate this using trapezoidal rule. I have to fit a straight line. So obviously there is so this is the difference. So my trapezoidal rule will not give the exact answer. Okay, so the option C is the incorrect one. Right. Yeah. So this is a basic question from the integration. So what is the meaning of the definite integration? What is the meaning of this a to b and this integration symbol fx dx? What is the meaning? Okay. So yeah. So you can see that this option A is the correct answer. This is the area below the curve from A to B. This is the definition for the definite integration. So your option A is the correct answer. Right. Now here you need to calculate the truncation error in this formula. Okay, so how to find it? Suppose here we have to assume that h is a small term. Okay, then I can use the I can use the Taylor series approximation around the point x. H is the information of the point x. So I can write in this way: f of x plus h f prime x plus h square by 2 f double prime x, and f of x minus h is equal to fx minus h f prime of x plus h square by 2 f double prime of x. Now f of x plus h, if I just subtract this minus f of x minus h, it will give me 2h. Oh, sorry, I should increase it by another term. So it will be h cube by 6 f triple prime of x, it is a triple prime, minus h cube by 6 f triple prime x. So now if I just subtract these two, suppose this is equation 1, this is equation 2, I am doing 1 minus of 1 minus 2, it will give me 2h f prime x plus h cube by 3 f triple prime of x. If you do this the subtraction, it will give you this answer. Now if I want to find the value of f prime of x. This is my agenda. So I divide it with it by 2h. So it will be, so then f prime of x will be equal to fx plus h minus of x minus h by 2h minus h square by 6 f triple prime x. So what is the order of the error? The order of the error will be f of x plus h minus f of x minus h o h plus order h square because of this term. Now, if someone tells you how what will be the order of the, so we know that this is the center difference divided difference approximation. Now, for FDD or BDD, you will find from this calculation, from here you can find the error in the BDD, and here from here you can find the error in the FDD. You will find that f prime of x as the order of h. Okay. Now what is h here? H is the step size. So you can do a very simple exercise. Okay. Take a function, some initial guess. Okay, suppose the simple one, the e to the power x. Okay, and you want to find the value f prime of x at e to the power 2 at x equal to 2. You want to find the value at x equal to 2. Huh? You can take h. Uh, you can take some values of h. Okay, but in the decreasing order. Suppose you can start with 0.1 and you can go up to 10 to the power minus 4 using some step size. Okay, you will see that your forward difference or the backward difference, this is FDD or BDD. Suppose this is the error and this is the step size. Actually this is the, I think it will be the opposite, right? So you will find that with the decrease of the, if you continuously decrease your step size, you will find that in your center different approximation, the error will reduce much faster compared to the forward difference or the backward difference scheme, because here the order is of h square. If you reduce your error by 10 times, then the error will be reduced by the 100 times. But here, if you here for the same forward or the backward difference scheme, If you reduce the error by 10 times, if you reduce the step size by 10 times, then the error will also reduce by 10 times. Okay, so that's why your if the CDD will give you much better approximation in this case. Now here we need to find the value of the integral using this step size 0.25. Okay, now the integration varies from 0 to 1. Just a moment. So your a equal to 0, remember the formula for the trapezoidal rule, that is fx equal to h by 2 fa plus fp, the summation I equal to 1 to n minus 1 2 times f of a plus I h. This is the formula. Now, so h is what? H is b minus a over n. Now here in this question, your b equal to 1, a equal to 0. H is provided, so 0.25 equal to 1 minus 0 over n. That means your n equal to 4, right? So it will be f of 1 a plus h, f of a plus 2h plus f of a plus 3h with 2 multiplied. Okay, so yeah, the value of h is provided. So I will just write the expression in this formula. I will just write the expression in this formula. Then I will calculate the answer. So here f of x will be 0.25 by 2 times f of a. What is f of a? That is f of 0. F of b is f of 1 plus 2 times f of a plus a, that is 0.25, plus a plus 2h, f of 0.5 plus f of 0.75. So it is equal to 0.125. If what is the value of f of 0? Okay, you need to find the values in calculator. I have already calculated this. So I'll just write the expression. And f of 1 is your 0. F of 0 is 1 plus 2 into 0.968 plus 0.866 plus 0.661. Okay. So what will be the final approximate answer? It will be 0.749 if you do the calculation. So option C is the correct answer. Okay, just straightforward calculation using the trapezoidal. Just calculate the number of segments that is present, so you will get an idea of how many summation that needs to occur, and you are ready for the solution. Okay, yeah, so this is one another straightforward question. You need to find the derivative of this function using three different schemes: FDD, BDD, and CDD. Okay, just a moment. Okay. Now here your x equal to 3. Okay, so I can guess. I can guess. So here I should have provided the value of the age, but I haven't provided it. So let us make a guess of h equal to 0.1. Okay, so what will be for the FDD? What will be the answer? So f prime of x equal to f of 3.1 minus f of 3 by 0.1. Okay, so let me calculate the answer. So this will be 2 into, so I can take 2 common, 2 by 0.1 into e to the power 1.5 into 3.1 minus e to the power 4.5. So what will be the answer? So 1.5 into 3.1 is 4.65, e to the power 4.65 minus e to the power 4.5. Yeah, this is multiplied by 2 divided by 0.1. So you will find that the answer is close to 291.357. Now, what is the analytical formula for analytical expression f prime of x? Analytical expression is 3 times e to the power 1.5 of x. Okay. So if I want to calculate the analytical expression, it is e to the power 4.5 times 3. So the correct answer is 270.05. This is the analytical expression. Now, now you can do the PDDs in the similar way. Here I am just writing the expression. Just calculate it. You will find that the difference is large. Like here, the difference is almost 21. It will be f of 3 minus f of 2.9 by 0.1. So kindly calculate the value here. Now let's check the CDD. So here f prime of x will be f of 3.1 minus f of 2.9 by 2 into 0.1. So what will be the value? So it will be e to the power 1.5 into 2.9. So here you will get that 27.1. Here you will get a 2 common, 2 by 2 divided by 0.1. So this value is approximately come as 271. Okay. And you can see that it is very close to the exact, it is very close to the analytical expression. So you can see that CDD is much far. You will find that BDD is also the value of the BDD, the difference between the BDD and the correct answer, exact answer is sufficiently large. So you can see that performs much CDD performs much better compared to your FDD and the BDD scheme. Okay. Yeah. This is a another problem for the numerical differentiation. Here it is provided that, once again, here you are already provided with the solution. Okay. The solution is already given using one of these method. You need to find which method is the correct one. Okay. Now here fx is equal to e to the power x. Right. Now f prime of x, here h is, you need to take h as delta 2. F of x plus h minus fx by h. So it will be e to the power 2.2. Just a second, huh? I'll be back. So this will be e to the power 2.2 by minus a square by 0.2. This is for the FDD scheme. Okay. If you calculate the value, it will be 8.175. Okay. So obviously this is not the correct answer. Now if you use BDD scheme, you will get that f prime of x is equal to f of x minus f of x minus h divided by h. And h is 0.2. So it will be e to the power e square minus e to the power 1.8 by 0.2. You will find that this value will be 0.69. Okay. So this is close to this expression. So the correct answer will be BDD. Now if you use CDD, we have already seen that CDD will give much better approximation. So if you calculate using CDD, you will get that this answer is 7.438, which is much closer to the exact analytical expression for the f prime of x. Okay, right. Now, so this problem is little tricky. You can this is a old gate problem. So let's solve it. So here it is said that here you are provided with you are provided with an integration. The exact integration answer, the exact solution is IE. The solution that we will get using the trapezoidal is IT, and using the Simpson's rule is IS. Okay. So and you need to find what is the correct answer. So first thing, so first we need to find what is IE, the exact solution. I is equal to 0 to 4 x square minus 4 dx. So it will be x cubed by 3 minus 4x 0 to 4. So it will be 64 by 3 minus 16 is equal to 16 over 3. Now, so while discussing about the Simpson's rule, I have told that Simpson's rule. So the basis function for the Simpson's rule is the quadratic polynomial. So if my function is already a quadratic polynomial, then Simpson rule will give the exact answer. Okay. Here I have x square minus 4. Huh. So let's verify if Simpson's rule can give me the exact answer. Okay. So let's verify that. So what can I do? That is, okay, another information is provided that the sub-interval used is the new in the numerical method is h equal to 2. Okay. So the Simpson's formula is, if I apply the Simpson formula, it will be 1 over 3 f of 0 plus f of 4. So f of 0 is the starting point, 4 is the last point. Okay, plus 4. 4 into the odd numbers. I mean the number that appear in the odd sequence, that is from 0 is the even, then 1 appears in the odd sequence, 4f1 plus 4f3 plus 2f2. Okay, so this will be the answer. So if you calculate it, you will get that f of 0 is minus 4, f4 is 12 plus 4 times f1 is minus 3, f of 3 4 into 5 plus 2 into f2 2 into 0. If you calculate, you will get the 6. It is 16 by 3. So IE equal to IS. So we have found that already. IE equal to IS. Okay. So from your understanding of the Simpson's rule theory, you can directly write this answer for finding the correct option. Okay. But here I have shown that it will indeed give you the exact answer. Okay. Now IT, that is the solution from the trapezoidal rule. IT. So what will be, so here I will have two segments. Okay, so 2 over 2, so I can divide it in this way, 0 to 2 fx of dx, we have solved a problem similar to this for the exactly the same limit, plus 2 to 4 fx dx. Okay, so it equal to 2 by 2 f0 plus f2 plus again 2 by 2. Here it is 2 minus 0 by 2. Here it is 4 minus 2 by 2. F of 2 plus f of 4. So if you find the result, it will be minus 4 plus 0 plus 0 plus 12 equal to 8. So IT is greater than IS equal to IE. So this is the correct order. So what will be the correct answer? Option B is the correct answer. Okay, I hope this is clear what I have done here. Now again another gate problem. So here you need to find the value, and the value is already provided using two subintervals. Okay, it is not told if the subinterval is if the age for the if the subinterval length is same or not. But for the simplicity, I can take h equal to 2, because I need to have two subintervals. So 0 to 2, one subinterval, and 2 to 4 is another subinterval. Okay, and it is 0 to 4, 2 to the power alpha x dx, and I need to find the value of the constant. The solution is given that the final result is 9, so I need to find the value of alpha. Now for 0 to 2, I just need to use the trapezoidal rule. 0 to 2, it is I1 equal to 2 minus 0 over 2 f of 0 plus f of 2. So it is 1 plus 2 to the power 2 alpha, right? Now I2 is from 2 to 4, that is 4 minus 2 over 2 f of 2 plus f of 4. So this is equal to 2 to the power 2 alpha plus 2 to the power 4 alpha. So what will be the final answer? I equal to I1 plus I2, and this result will be equal to 1 plus 2 into 2 to the power 2 alpha plus 2 to the power 4 alpha. Okay, equal to 1 plus 2 to the power 2 alpha whole square, and this equal to 9 equal to 3 square. So I can write that 1 plus 2 to the power 2 alpha equal to 3. I am taking the positive value. This implies 2 to the power 2 alpha equal to 2 equal to 2 to the power 1. So alpha equal to half. So this is your correct answer. Okay. So very straightforward idea. You just need to find the, you just need to use the trapezoidal rule, and you need to find the constant. Okay, that's all. Okay. Now, so now this is the last question. After that, we will directly go to the problem. We will go directly go to the coding part. Okay. So let's solve this last question. So it is provided that using a two segment Simpson's rule, the value is 500. Okay, so it is already provided. Now I need to estimate the value using the four segment Simpson's rule. All right. So what will be my h over here for the format for two segment Simpson's rule? H will be equal to 21 minus 5 by 2 equal to 8. Then what will be the integration result? It will be h over 3. That means 8 by 3 f5 plus 4 into f of a plus b by 2. That is 4f13 plus f21. This equal to 100. It is provided. Okay, let's keep it. Now for n equal to 4, what will be the h? H will be equal to 21 minus 5 by 4 is equal to 4. Now what will be the result over here? So this is I2, maybe this is I4. I4 will be equal to 4 over 3 F5 plus F21 plus 4 F9 plus 4 F17. Because why 4f9 and 4f17? Because 5, 9, 13, 17, 21. First segment, second segment, first segment between 5 and 9, second segment between 9 and 13, third segment between 13 and 17, and the fourth segment is between 17 and 21. So this is the odd point. This is also the odd point, and here only 13 is the even point, and these two these two are the ending point, starting and the ending point. So it will be 4f9 plus 4f17 plus 2f of 13. Okay. Now from this expression I2, so suppose this is equation 1, this is equation 2. So from this expression, so what I can write? I can write that uh, so from equation 1 I can write 4 by 3 f5 plus f21 is equal to 250 minus 4 by 3, not 4 by 3, minus 16 by 3 f13. Yeah, I can write that. I am dividing it by 2, so it is 500. Here it is all in on the left. Here in I4 it is 4 by 3. Now if in this expression I can find that 4 by 3 f5 plus f21 is equal to 250 minus 16 by 3 f13. So I can substitute it in the expression of I4. So what will be I4? I4 will be equal to it will be equal to 250 minus 16 by 3 f13 plus 4 by 3 4f9 plus 4f17 plus 2f13. So if you do the calculation, you will find the final answer will be 250 plus 8 over 3, 2f9 plus 2f17 minus f of 30. So this is your This is your answer. Okay. So I will share this document with you. But now comes the important part. Now we need to solve this using MATLAB. Okay, because if I have to use two segment or three segment or four segment, I can easily use trapezoidal rule and Simpson rule and do the problems by hand. But real problem in real problem we cannot do that. In real problem we need to, for accurate answer, we need to use 300, 400, 500 segments. It is possible. So there we need to use MATLAB for that. Okay. So now using MATLAB, I will teach you how to use the trapezoidal rule and the Simpson's rule for the numerical integration. Okay, so let me open that. Right. So the first problem is, one second. So here I have not written the expression. So what you need to do here, you are provided with an expression. You do not need to know the physics of the problem, but you just need to solve it numerically. So it is 3000 log 150000 by 1540 minus 1500 t minus 9.8 t dt. This is the position. This is the vertical position of a rocket. Okay, this is the expression for that, and you need to solve it numerically. Okay. Now here what I have done in the first example. So this is an analytically solvable problem. Okay. Here I have used MATLAB to do that. So first I have defined a symbolic function, symbolic variable, that is z. Now I have written down the expression 3000 log 15 15 1 1, 2, 3, 4, 5, 6. Yeah. So this is 150 100. Yeah. So this by so I have so here I have written the expression. And in the first class I have told that in MATLAB, if you want to do the symbolic integration, it is the command is int x, that is the function what you need to integrate for the starting point and the ending point, x 830. Okay. So race 2 is the solution, result 2 I have written in this way. And VPA. So if you solve it, so it will give you some analytical expression. Okay, but it will not give you any numerical value. To find the numerical value, you need to use VPA. Please see the use of the VPA. I have already discussed in the past class. So here here in the res here in the result 2, res2, it will give you some function like log of, suppose, 30 plus log of 8, something like that. Now if you want a numerical value out of it, you use VPA. And here 9 indicates the number of significant digit that I want in my expression. Okay, I want 9 significant digit in my expression. That is probably, suppose I have a number 15307.88988789. Suppose I have this expression, but I just need 1.15307.88. Okay, then I will write, suppose this expression is ex VPA ex comma 1 1 2 3 4 5 6 7 7. If I it will count first 5 point, then 2, VPA ex of 7. Okay. Now, this first part is the analytical solution part. Okay. I will erase this. So this is for the analytical solution or the exact solution, i.e. Now I will use the trapezoidal rule to solve this problem. So here I have defined what is B and what is A. A is 8 initial point and B is 30. Now I have used 30 segments. Okay, because you can very easily see that this problem cannot be solved by hand. I need to use Matlab. Okay, here I am using 30 segments. I will share you the code with you. So you change the value of n from 2 and increase it up to 20 to 20 or 30 anything. You will see the error will gradually decrease. Okay, you to get a good estimation for this x. You need to use this large amount of this large number. Okay, now, and we have already discussed about the formula. What is h? H is the step size, b minus a over n. Okay, and here I have written f in this function form. Okay, you will see why I have written it in this way. F equal to at the rate. So here I have defined a function like it. Okay, at the rate a and the expression. Now here so remember the expression. What was the expression? Expression was b minus h over 2 f of a plus f of b plus 2 times I equal to 1 to n minus 1 f of a plus I h. So here what I am doing, so here this is a loop which is running from 1 to n minus 1. So it is sum equal to sum I have predefined is at 0. It will continuously add it. Okay, and finally this is the solution h by 2 fa plus fb plus sum. Okay, and here solution, what is the error? ERR is the error, that is the absolute value. So this is the absolute error. Okay, so sol is the exact solution and sorry, sol is the approximate solution and res2 is the exact solution. Okay, and here ERR equal to double ER, that means see I have defined a symbol and all the work I have done with it. The finally you will see that when you do the code, err will appear at 1 cross 1 sim. It will appear as a symbol. Now if you want to get the numerical value of it, okay, just use this command double. See, it will convert the symbol to a number. Okay, so what is the answer? The answer is 0.4593. So this is your answer. Okay, I will share it with you, but please, I will erase this. Just a second. Huh? Sorry for sorry for that. So yeah, so please, so here in the next question, so here I will show that what happens if I increase the step size gradually. So the code is exactly the same, but here I am using an extra loop because here I am gradually increasing the step size. So here this capital N, okay, capital N is varying from 2 to 30. Okay, that is the number of segments you will see. So there will be an outer loop for this capital N. So, and here, yeah, here the loop starts here. The loop starts here. This N equal to capital N of J. Okay, and I am doing the exactly the same calculation, the same thing I am doing over here. But here I have defined error as a vector because I have to do that because I want to finally get a plot. The plot will be capital N versus this error. Okay, and then after that I have plotted the result, and this is the solution. So this starting at the starting, that this is at n equal to 2, you will you can see that the error is 100. And after some and after and if I and now as I have increased my now as I am gradually increasing my step my segment size, segment number, you can see that the error is decreasing rapidly. Okay, this is almost an exponential decay, faster than the exponential decay. Okay, so so this is the reason you need to use MATLAB for this kind for this kind of calculation. So you can see that n equal to 2 is not the answer is not, and the difference is very large. The absolute error is 100. Even this is the 50, here this number of segment might be 6 or 7. Okay, it is also sufficiently large, but after 30 step, but after when n equal to 30, we have seen that the absolute error comes down to 0.459. Okay, this is a significantly small number, and we can accept that. Okay, so try this for different kind of function. So in the next example, so let me erase this also. So in this example, I have considered another function. Okay, I will do exactly same operation, but here I will use another function. Okay, just to see what happens for what happens about the error. So here my fx is e to the power x by 1 plus e to the power x. This is also an analytically solvable expression. So here this is the solution. Okay, so this is a here I am analytically doing the solution. E- exactly the same code, just the function is different. Okay, and and the limit also different. Okay, so the here a equal to 0 and b equal to 5. So here you see that I am using two segments. Okay, and h equal to b minus a over n, and exactly the same thing, and I am getting an error of 0.1366. Okay, now this value of error is so this absolute the absolute error doesn't tell you if this is a if this is a significantly small number or not. In order to do that, you need to find a relative error, because if your value is 0.2, then 0.126 is a significantly large number. Okay, but if your exact solution is 5,000 maybe, then 0.126 is a very small number. So it is so I haven't done it here, but it will be better if you use the relative error. Okay, just divide the absolute error by the absolute value of the exact number. Okay, then you will get the relative error. Now now here I have done the same thing. I have plotted the error curve. Okay, so you can see that the error starts from a small number. We have seen that it is 0.1366, and the pattern is exactly similar, a very sharp decay when I increase my segment size. Here I have increased the segment size to 50. Previously, in the last example, the maximum value I have taken as 30. Here I have increased that. Okay, the code is very fast. You will if you when you do it in MATLAB, you will see that the code is very fast. You can see that after maybe 25 or 26, there is no significant change in the number. It is almost zero, so we can say that the value is saturated. Okay, so we can stop at 25 or 26. Okay, now now this is the code for the Simpson's rule. Okay, I will solve the same problem. So is it the last problem? No, this is not the last. One second. Yeah. Okay. So here you need to use the Simpson's rule to solve this problem. Okay, so this expression, this same expression. Now here you will see that how Simpson's method modify the answer massively compared to the trapezoidal. Okay, the answer is much accurate compared to the trapezoidal rule method, and you will see that here the error reduces drastically. Okay, here you can see a smooth decay for the trapezoidal rule, but when I show you for the Simpson, you will see that it is nearly a straight line and just then zero. Okay, a very sharp decay will occur for the Simpsons rule. So so yeah, another thing. So this is the numerical way. Okay, so I will take you later. So this is the analytical way of solving the expression using int. Okay, int, and then you change the symbol to a number using VPA. Okay, I hope this is clear to you. Just if it is not clear, then just write in Matlab help int or help VPA. It will give you the total. It will give you the complete documentation. So everything is same. Okay, but the main body has changed. So remember the formula. The formula was h by 3 f of x naught plus f of x n plus 4 summation I equal to 1 to n minus 1, but I will consider only odd terms, f of x0 plus ih plus 2 summation I equal to 2 to n, sorry, I don't have space over here, plus 2 summation I equal to 2 to n minus 2, but on the consider, it will consider only the even terms, that is f of x0 plus ih. Okay, so here, unlike the trapezoidal rule, I need to use two summation. Okay, that is not a problem. So some here I have predefined sum one and sum two, both as zero. So here, so yeah, so now it will only consider the odd terms. So one, one, two to n minus one. So after one, it will take three, then it will take five, then it is seven, and so on. Okay, and this is the first summation, and this is the second summation. So I equal to 2 colon 2 colon n minus 2. So the first term will be 2, then 4, then 6, then so on. Remember that here here you here there is a restriction on the choice of n. So let me write in red. N is the even number. Okay, you need to select n as a even number always. Okay, in for the Simpsons rule. Now after you have found that sum 1 and sum 2, then the final solution will be solution equal to h by 3 fa plus fb plus sum 1 plus sum 2. Here sum 1 is the this summation four times this summation, this expression, and sum 2 is the two times this expression. All right, now what will be now, here I have defined the error again. I am calculating the absolute error, but it will be better if you calculate the relative error. Re slash err is equal to err divided by abs of res 2. It will be better if you use the relative error, but you can see the difference. Here error is 1.5 into 10 to the power minus 5, and I have used total 30 segments. For the same problem, same interval, for the trapezoidal rule gives me the error of 0.4593. Okay, and Simpson's rule will give you 1.5 into 10 to the power minus 5. So you can see that this error is sufficiently much larger than this. Okay, which in the which indicates that if if you are satisfied with this kind of error, this 0.0, this is actually 4.5 into 10 to the power minus 1. Okay, so this is of order 1 and this is of order 5. Okay, if you are satisfied with this error, then for the Simpsons rule, you do not need to choose n equal to 30 here. Because 30 is a sufficiently large number of segments. You can take 10 or 12 this thing. The for the for this will give you the similar answer. Okay, like the trapezoidal rule. So what trapezoidal rule can do for the 30 steps, the Simpson's rule can give you the same answer for 10 or 12 steps for this particular problem. Okay, for other problems there will be some other answers also. This may vary, but Simpson's rule will always give you better approximation compared to the trapezoidal rule. Now, so now I will do the error plot. Okay, for the Simpsons method. So here the only the difference is comes here, that I cannot consider the odd number of segments. So here n is varying from 2 colon 2 colon 30. Okay, so this will be the correct choice of n, capital N. So this outer loop is for capital N. Okay, so here n equal to n of j. Okay, and all other operations will be same. So first you need to define the what is h, that is b minus a by n. Okay, and here I have defined the function. Yeah. So I haven't told here that why I have defined the function, because then I can write this thing very easy. If I have defined the functions like this, f equal to suppose some function at the rate x, maybe exp of x sin x, there will be a star sign over here. Okay, then I can easily write f2, f3, f4, blah blah blah, anything. Then it will give me exp2 into sine 2, exp3 into sine 3, this kind of answer. Okay, so so I have used the shorthand notation of the function. Okay, just to write these expressions. Otherwise this is not necessary to write it. So I have defined my sum over here, sum 1 equal to 0, sum 2 equal to 0. Remember that you need to define that sum 1, sum 2 inside the loop of n. If you define it outside, then after one loop, then your sum is not 0. Your sum will have some value from the previous loop, and it will accumulate, and finally it will give you the wrong answer. Okay, so you need to write the sum 1 equal to 0, sum 2 equal to 0 inside the loop of n, capital N. The same thing will happen for the trapezoidal rule case also. Where I have done that. Yeah, here see that I have mentioned I have mentioned here I have written the I have defined the sum equal to 0 inside the loop of capital N. Okay, not outside it. You need to keep this in mind. So So sum 1 equal to 0 and sum 2 equal to 0. Now sum 1 is is this. It will only contain the odd terms 1, 3, 5, and so on. Okay, n equal to 1 to 2 to n minus 1. Sum 1 equal to sum 1 plus 4 into f a plus ih. Okay, this will be your sum 1. And sum 2, this is for the even terms, that is 2, 4, 6, and so on. There is 2 colon 2 colon n minus 2. So sum 2 equal to sum 2 plus 2 into f of a plus ih. Okay, and here you need to, here this is the solution, that is h over 3 fa plus fb plus sum a plus sum 1 plus sum 2, and this is the error. Remember that we have defined error as a vector. Now if I just plot the solution, yeah, so you can see that decrease, it decreases gradually. Okay, so this will be what, this is maybe after 15 maybe. Okay, not 15, so this is 20, so it, so no, this is 20, so this is 10, so it is almost zero after 7 years, after 7 segments. Okay, so this is n, this is error, right? So it is almost zero after it is almost zero after 7 segments. Okay, not 7, it can be 7, it may be 8. Okay, it is almost zero after that. But for the trapezoidal rule, for the same problem, you can see that it goes to zero after 20. It goes to approximately zero after 20. Okay, so this is the power of the Simpson's rule. Now, okay, so here I have shown an example. Okay, so here I will, here now Matlab has some inbuilt command for integration. I have an, so in the first class I have mentioned that diff, using diff you can do symbolic differentiation. Okay, so for that you need to, so I haven't, as I told you in the first class, I haven't done any code here using that, but I can mention it. So in that case you need to define this like this. So suppose t, and your f equal to, suppose, sine of t times exp of t. Now if you want to find differentiation, okay, you just need to use diff of f, and it will give you the answer. Okay, you try this. Now if you don't want to use symbolic integration, symbolic differentiation, and you have some data points. Okay, now in reality, suppose you most of the time you will not get a good function, you will get some data point, and you need to find the derivative of that. Okay, suppose you had some data point x, like, sorry, suppose fx equal to 0, 2.2, 2.9, 5.7, 3.8, and so on. For that, there is a inbuilt command, in MATLAB, that is called gradient of f. Suppose you defined your f like this, a vector, and use gradient. Now remember, suppose you have, in f you have, suppose this number 2.2 colon 2.5 colon 2.7 2.3.8. Okay, now for, now it will give you, now gradient of f will give you f prime of x for all the points. Okay, now it does one interesting thing. For the first point, it will use fdd. For all the intermediate points it uses cdd, and for the last point it uses bdd. You need to keep that in mind. Suppose you have in mind suppose you have a data set, and you want to find the value at some approximate point, so it will be always better if you take, suppose you need to find the value at xi, so it will be always better if you take xi plus xi plus h, xi plus 2h, and xi minus h, xi minus 2h. Then you will be safe, because for this xi you are sure that that this gradient, this inbuilt format, it is a very powerful tool. You can use it every time. That the cd that the for the xi, the MATLAB will use the central difference divided difference scheme. Okay, but if you just use the 3 points, for this point it will use the BDD and FDD. Then your solu then then in this case your solution will be more accurate, because we have already seen that for CDD the solution is more accurate compared to the BDD and the FDD scheme. Okay, so this too I wanted to mention, that this is for the differentiation. Now remember, yeah, one thing that I forgot to mention, that this gradient actually calculate the differences. Okay, now suppose you have something like this: t equal to 0, 0.2, 0.4, 0.6, 0.8, 1.0, and x equal to 1.1, 1.5, 1.6, dot dot, same. The length of these things are same. Now gradient of x will not give you the velocity. Gradient of x is equivalent to d of x. You need to divide it with the gradient of t. Only then it will give you velocity. You need to keep in mind this thing. Okay, because gradient of x only give you the differences. Okay, I should have shown one example here. I will show it in the next class. Okay, but but keep this in mind. So just write help gradient h in small case. You will see that whole documentation on this gradient. Okay, g, small g, sorry, here all of these are small case letter. Gradient. Okay, now, like the differentiation, also there are some tools for integration as well. Okay, so here there is one example: trap z. Suppose you have some, this is similar to the gradient, just the opposite. Gradient create differentiate, trap z integrate. Trap z is the inbuilt tool for trapezoidal. This is the inbuilt function for that. So this is the same example. This is the same example where we have already solved it by hand for the question 4. So here you are given a data point, and the delta t is not constant here. Okay, and you are given a velocity field. Now what is what will be the solution? The solution will just do trap z t. T means the independent variable. Trap z t with respect to v. Okay, you can, it is actually v dt. This is the interpretation, but using the trapezoidal way. Okay, trap z t v, and it will give you the solution. If you just write trap z of v, okay, it will assume that the delta t is uniform, and it is equal to 1. If it is something other than 1, you need to specify it over here. Okay, so this is also another powerful tool. This will be applicable when you have data set. Okay, when you have data points, discrete data points like this. Now suppose if you so this is so I will finish after this. So this, suppose if you have some continuous function, okay. So there is so we have already discussed about the int is applicable for the symbolic computation. It calculates the value symbolically, okay. But if you have a function and you want to calculate, and there may be, and there will be infinitely many functions which cannot be solved which cannot be solved analytically. Sims gives you the analytical solution. But suppose if you have a complicated function, okay, and then Sims sorry, not Sims, int, and then their int will not work. So what you can do there, okay. So there is a function that is called integral. Here also you have to define a function like this: f equal to some at the rate x, maybe some complicated function exp of sine x cube. I think this is not solvable analytically, okay. But using this integral we can very easily solve it, okay. So let me write it here. So I will show an example of this in the next class. So integral, first you need to define the function f equal to at the rate x dot dot something, integral f, then xi is your initial point, and xf is your final point, and you will get the numerical value for your answer, okay. This is also another powerful tool. You will if you so with experience, so in my experience I have observed that it may vary from case to case, but I have observed that integral works much faster compared to the trapezoid, okay. There are some symbolic, you can do in case of symbolic computation you can do VPA integral. VP in case of VP integral, you can calculate the answer numerically for the symbolic for the symbolic toolbox, okay. But in my experience I have seen that integral works much faster than the VPA integral, so I try to avoid this, okay. So in the next class I will show, so I hope so. So today we have solved the trapezoidal rule and the Simpson's rule from scratch, and I have shown that Simpson's rule work much better compared to the trapezoidal rule, and this you can see this from this error diagram. Okay, Simpson's rule converges much faster, and here I have discussed some of the aspect of the inbuilt MATLAB differentiation and the integration process. Okay, so in the next class I will show some example. I will show some small example of this. Here I have shown one example for this trap Z. Okay, I will show the example for this differentiation and the integration. So the differentiation, I will show the example for this diff and gradient. Okay, and how can I calculate velocity using this gradient? And I will show an example of this integral and the VP integral. Okay, so yeah, so that's all for today. So I will share this code with you, and I will meet you in the next week. So thank you. Good night.